All right, so we'll get started. Welcome, everyone. Thank you for joining for this is session 3. We're going to focus on subtraction today. If you have not attended before, we have done the first week was about why do we do the new strategies that we do for math. We also looked at the early learning progressions of number and counting. Last week we did addition strategies, and we looked at a routine and a game that you might play. Those now can be found on the DOE website as a recorded training, and you can watch those recorded trainings. You can still get contact hours for them, just like you'll get contact hours for viewing today or being part of this today. We will be working next week on multiplication and then division, and then finally we'll kind of wrap up in June with our strategies and routines that you might do to support student needs. This is a learning experience for all of us. The number of participants has been amazing. Trying to get certificates out to everyone has been quite a chore. I learned a little bit, if you've watched last week's video, I have learned that I need to record it in slightly different ways so that you can actually see what I'm doing and not just my little picture mixed in amongst 20 other pictures. So that is a learning experience for me, and I think I know how to fix that problem. So we're going to try to do that this week. So like I said, you will get contact hours at the end, so please don't leave without getting the link for that. And if you have trouble with the link, you can always email me. But I did want to make sure that I let you know this week's contact hour certificates are going to take me a little longer to get out because we do have a training, a couple of other trainings that we were supposed to do in live that we've pushed back and are now doing virtual trainings, but certificates will be coming for those folks as well. And so it's an additional about 100 people. So I will work through the weekend. We'll get them all out by the end of the weekend. By Monday, everybody should have their certificates. If you're viewing it live and you're here today, then most likely you'll get your certificate sooner rather than later. It's those who are watching the videos that sometimes are getting pushed out a few extra days. But if you go in to watch weeks 1 and 2 at this point, they are automated and you should get your certificate right away for those trainings because I have turned them over to an automated system. And along with the information about surveys, please make sure that you double check your name and your email address, because if certificates get bounced back to me, it's I am going through and trying to find the corrected email address, but sometimes I'm having to do a little research as to which district you might be part of. So just make sure that the district number is correct and that whether it's .org or .com or .main, just make sure that those pieces are accurate in your email address so that I can get those certificates out to you without a problem. So we will get started with subtraction. I'm going to share my screen, and one of the things that we talked about last week was where do we expect to see these standard algorithm, the US standard algorithm, the way that we were pretty much taught, where do we see that they should be fluently used according to the Common Core standards? And when we looked at addition and subtraction, both actually show up in grade 4. So you're not just learning it starting in grade 4. You actually are starting with addition and subtraction strategies much earlier. You're starting them in probably kindergarten. But you do not have to have fluently learned the standard algorithm until grade 4. So we'll talk about how the strategies that we're going to use in grades K, 1, 2, 3 lead up to what we're asking students to know fluently in grade 4. So let's get started with some of our strategies. I'm going to see if I'm going to do a new share. So one of the first ways that students might use subtraction or do subtraction is that they start to look at what does subtraction mean, right? So we can talk about subtraction as an action of taking something away, We can talk about subtraction as a comparison. And sometimes when we start looking at subtraction, we use those terms difference. So when we subtract, the answer that we get is called the difference. And we start to think about that as a distance between the two numbers. So if I had, I'm just going to kind of give you a quick scenario. If I have $10 and you have $6, the difference is $4, but the distance between 6 and 10 is 4. So we can also talk about that distance. So we might use a number grid where students are actually either counting up or counting back. So if I have the problem 67 minus 32, here's 67 and here's 32, and I want to find the distance or the difference between these two numbers. So a student will initially start counting back one by one. They will count back. As they increase their skills, they'll start to recognize that when they count back by tens, it moves a row in the number grid. So that is just like addition, you can either add or subtract, you move rows. It's that tens place value that's changing, but the ones place value stays the same. So if I want to find out what the difference is between 67 and 32, I can count backwards 10, 20, 30, 31, 32, 33, 34, 35. And that's my difference. Now, a student may also count up to find the difference. They might start at 32 and count 10, 20, 30, 31, 32, 33, 34, 35. So they can get to the difference or that distance between the two numbers in two different ways, but that's because they're looking at the relationship of those two numbers instead of just thinking about it as a takeaway problem, and I can only take away. So they may count up or count back. They start using, they're counting by ones. They might move into those tens and ones. And then they might start to think about moving away from the number grid. So let's look at what that might look like. So if I am now moving into maybe some base 10 models, I'm going to think about using base 10 blocks. And so when we do that, we want to start with that concrete model. We'll actually have students using the base 10 blocks to model the subtraction. So they start with their whole group, and then they subtract or take away the amount of blocks that are being subtracted away. Once they get that concrete kind of block model, we're going to start using base 10 shorthand. And so that is using the pictures of base 10 blocks, and I'll show you how we're going to model that. So if I have the problem 72 minus 34, and with addition, we would make two groups, and we would then put those groups together. In subtraction, we start with this big group, and we're going to actually model the takeaway, the removal of the second digit here, the second number here, the 34. So I'm going to try to draw these so you can see them. We're going to start with 72. So 10, 20, 30, 40, 50, 60, 70. So this is shorthand. Base 10 block, this is a shorthand for a 10. Sometimes we call it a long. So that's why it's not a tally mark. It's a base 10 block. So 72. And I'm now going to remove, and I'm going to just kind of make myself a space to show where I am moving those blocks to. I'm going to remove 34. So I'm taking these three 10s and I'm going to move them here. So 10, 20, 30. So I no longer have them here. And now I still need to take away 4 because I've taken away 30. I need to take away 4. So I'm going to take away, well, these two blocks here are going to come down here. So I'm going to remove them from here. But I still now need 2 more because I've only taken away 2 and I needed to take away 4. So I'm going to trade in one of these 10s. So this 10 now becomes 10 unit cubes. And I want to make sure that I'm modeling out those 10 before I take them away. Because if I start with the 2 and go, oh, I'm going to put them right here, I lose track of that trade. So I want to make sure I make the fair trade first, and then I can take them away. So now I'm going to take these 2 and I'm going to move them over here. So I started with 72. I have now removed 34, and I'm left with 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38. So once students get familiar with using those blocks, they can move to that shorthand version where they're writing it out. They're drawing a model on paper. We may have them using the blocks and drawing the model when we're first starting so that they can feel and see how that transition looks. So they would then do this. So far, we've not moved into that standard algorithm at all. We're talking about building a number, 72, tens and ones, and then we're removing that number. So after we get done with our base 10 blocks, well, we're not really done with them. We're going to come back to those in a moment. But when we're moving on to a new strategy, we're going to start talking about an open number line. So let's model 452 minus 237. And so remember, we're talking about that distance. If we're talking about a number line, we're talking about that distance. My open number line is a number line that doesn't necessarily start at 0. I'm going to determine where it starts. I get to put the numbers in, and it's not going to be necessarily to scale. So I want to know 452 minus 237. So in this case, I'm going to start at 452, and I want to get back to 237. So I'm going to start here, and I'm going to work my way back to here.
Excuse me.
Yes.
Can you move the camera over? So, because right now your paper's in like half of the view. Yeah, there you go. A little more.
Is that better?
That's great. That's
all right.
Thank you.
You're welcome. All right. So if we're starting here, we're going to take away. We're looking for this difference. What is the question?
We before talked about when we were talking about the number square, the children could go forward or backward. If I have a student and the student leads with the 237, that's okay, right? But I still want to have the 237 to the left of the 452.
Yes, because the number line increases in value as we move from
number line.
It's a number line, and so just like if we started with 0 and our numbers would increase in the positive direction this way, we still want it to do that. I will model in just a second. We'll model counting up. For this one, we'll model counting back. So I'm going to now figure out how far is it from here to here. So if I'm going to jump back, I don't necessarily know how far it is. So I'm going to jump in distances that I know. So I'm going to start at 452, and I'm going to take away 100, and that leaves me at 352. Well, I know if I take away another 100, that's going to get me to 252. Now I might, I'm not so sure. I'm not comfortable necessarily with those numbers. Maybe I will take away 2, and I get to 250. I'm going to take away 10, and I get to 240. Well, now I know I only have to take away 3 more to get to 237. So I've broken that out. A student may know they could have taken away 1 jump of 200, but I'm breaking it out into the parts that I know. And as students become more efficient with this strategy, they'll start to look at how they can make those jumps more efficiently. A student may have to do 100, 100, and then they may have to go by ones until they get to where they needed to go. So now I want to look at how far did I jump? I jumped 100, 100, so that's 200, 202, 212, 215. So I jumped a total of 215. The distance between those two numbers is 215. Now, if I wanted to think about jumping up to count up, I'm still starting now. I'm going to start at the 237. And geez, I know that 237 plus 200 is 437. I now know, 437 plus 10
for the measurement?
Yeah.
is 447.
917.
If you would mute yourself
okay.
if you don't have a question.
Are you doing it in feet and inches, or are you just doing it in, are you doing it in percentages or fractions?
And then from here to here, I may have to count up. 447,
Fine,
448, 449, 450,
so
450, 450. Student will use what they know. They may also jump to 240, yes.
Jen, I had muted everybody, which meant I muted you, so you might want to jump back slightly. Sorry about that.
Okay, no problem, thank you. So if I jumped here, I'm now going to count up how far I jumped. So 200, 210, 211, 212, 213, 214, 215. A student will jump and make the jumps that they understand. Maybe they don't like working with this 237 plus 200. They may start with 237 plus 3 to get to 240. That might be a more comfortable number for them to work with. And then they could continue to make their larger jumps. Maybe I know 240 plus 60 is 300. And then I might know that 300 plus 100, if I'm headed to 452, 300 plus 152 is that distance to get me to 452. I can now add these up. So it's however the student sees those numbers, and they'll become more efficient as they practice with this, is just another strategy that's moving them along. It's building that relationship between the numbers. And they do the same kind of strategy with addition. If they're adding to a final number versus figuring out the distance, which is what subtraction is doing. We also might think about a student who understands compensation. Good. So 347 minus 298. A student might see that this 298 is really close to 300. So they might think about this problem as 347 minus 300. So they've changed the problem, but they can only do this if they're making sense of that those numbers and the relationship in those numbers. So 347 minus 300 is 47. Well, now I know I took away 2 more than I needed to, because I only needed to take away 298. So if I think about, I took away 2 more than I needed to, I'm going to add those back in. 47 plus 2 is 49. So my distance here, my difference is 49. If I look at these numbers, that in my mind, I make sense of numbers in that way. I say, well, it's kind of close. to 300, I can do that easier in my head. So they're building that relationship of the numbers and understanding how to think about those. They might also use something like a give and take. If I'm looking at 396 minus 172, I'm going to start with this number line, and I'm going to say, okay, 172 to 396. I don't like those numbers. They're not easy to use kind of numbers. So I know that 396 is really close to 400. So if I add 4 to 396, now remember we're talking about a distance, and we want the distance from here to here. So if I say I'm going to move up to 400, I've added on 4. If I add on 4 here and move to 176, this distance is still the same distance. I just shifted on the number line. And so now I can think about this distance or this subtraction problem a little easier. Because I could say, well, 400 take away 200 leaves me with 200. I then take away 24 more. So I've taken away 224 or 224. I just shifted on the number line. But the student has to understand the relationship between those numbers. Now, I don't expect a second grader, third grader maybe to start doing some of this. Not all students will move to this strategy. Not all students will see this, but some students might. So it's important that you understand about this strategy of just kind of shifting. You might think about it as like a give and take. I'm moving these numbers and actually using different numbers.
Jen, before you
Yes.
move on, there was a question in the chat box. What do you do with students who continually squish the numbers together on the number line and get confused as to where they landed or how many they jumped?
So for a student who does that, you may want to actually get out chart paper for them to use, something bigger for them to use so they can spread out their work. As they become more efficient, they won't need maybe as much space because they can make larger jumps. So they won't need to make, they could be making like 15 jumps on a number line in a problem until they start to see that they can put those together and make larger jumps. So you could get out longer paper. You might even get out like adding machine tape. If you have that around, often those are used as number lines in classrooms. You could also use graph paper or paper with lines. I know some people actually take a notebook paper, a lined paper, and turn it sideways so that the lines make kind of like columns to help organize student work. And in this case, when we're using the number lines, we are not looking for to scale jumps, right? I might make a jump of 200, but my jump of 200 might look sort of like my jump of 5, but it's how I'm labeling my jump. And so it's about being clear in the work. If we're going through a whole lot of problems in the hour that we're together, I certainly would not go through all kinds of different problems with students. I would stick with 1 or 2 good problems and work through those problems and give them time to work on those specific problems. One great problem and moving through different strategies is definitely gold because they can work through and see the connections from one strategy to another. And there are certain strategies that are better for certain types of numbers. So this problem here with compensation, you wouldn't use compensation necessarily if your numbers weren't close to nice numbers to change them to. And so that's where understanding the strategies and understanding what kind of numbers work best for those strategies is kind of part of, as you learn those strategies, you learn about what numbers would work best. And today we're not going to necessarily go over each one of those pieces because really we're trying to just get out the ideas of the strategies.
So the question that I have is, does the strategy change when working with decimals?
So it doesn't. You could do the same thing with decimals. You will have some pieces that might be slightly smaller. You have to think about a jump on a number line might not be a whole number jump. It might be a decimal jump, a portion of a jump. Same with this compensation. I might round up to a whole number and do the subtraction problem, and then I have to adjust based on what I did with that decimal number. So now we're going to look at expanded notation. We're going to expand the numbers out, and we're going to subtract by some place value, but we're also going to connect that to the base 10 blocks, and then we're going to connect that to the standard algorithm. So if we have something like 723 minus 465, I am going to use expanded notation. I'm going to expand out 723. So that is 700 plus 20 plus 3. 465 is 400 plus 60 plus 5. And now I want to subtract these. So I'm going to subtract by place. And so when I do this, I'm going to have to start thinking about, well, if I have 3 and I need to take away 5. In our problem with students who are working at this point, they have not learned about negative numbers. So they're going to say, I can't take 5 away from 3. And that's one of the things we want to be careful about saying, that we always take the smaller number away from the bigger number, or we say we can't take it away. Because we can take it away, we do end up with negative numbers. And some students might actually think about that. They might say, well, I have 3 and I need to take away 5. Well, I can do that. I still have to take away 2 more. I owe 2. I have to take away that. You can talk about that being a negative 2. And then we'll use that with the rest of our problems. So we just want to be careful about how we talk to students about numbers, because we can take a larger number away from a smaller number. And especially in a situation like this, we are breaking out a piece of this number. This number 3 is 3 in the ones place of 723. So if I have something like this, I'm going to actually draw out my base 10 blocks. So 700 looks like 1, 2, 3, 4, 5, 6, 7. So there's my hundreds plate. 20, so 2 10s, 2 longs, and 3 1s. And I need to take away the 465. So I'm going to be moving that 465 into my place that I've designated. And I'm going to say, okay, I need to take away here. I need 3 and I have to take away 5. Well, I have 3. I'm going to move those 3. Well, I still can't take away 5. So I'm going to make a trade with my base 10 block. So these 2 10s here represent the 20 here. So this is where I'm changing in my 20, and I'm now going to have 10. And I'm trading in this 10 for 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have 13 units. I have 13 ones. When I made this trade, this 3 became the 13 ones. I now can take away the 5. So I have 1, 2, 3, 4, 5. This is the group that went here. I no longer have them. And I'm left with 1, 2, 3, 4, 5, 6, 7, 8 ones. All right, now I'm in my 10s. I have 1 10. I need to take away 60 or 6 10s. So I'm going to make that trade. So I'm going to take one of these hundreds. And when I trade one of the hundreds, I'm going to get 10 10s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I now don't have 10 here. I actually have, I traded in the 100. I have 110, and I'm still left with 600 in my hundreds blocks. So if I'm moving out 60, so 1, 2, 3, 4, 5, 6 of my base 10 blocks, my base 10 tens, 2, 3, 4, 5, 6. I'm left with 1, 2, 3, 4, 5. 5 tens is 50. And now I have 6 of my hundreds blocks left. I have 600. I need to take away 400. So I'm going to take away these 4. And so when I did that, I have 200 blocks left. 600 minus 400 is 200. So I had 723 blocks, or base 10, my number, 723. I needed to take away 465. What I'm left with are 200s, 50, and 8, so 258. So we've seen how using the base 10 blocks connects to this expanded notation. And then if I'm going to leave this one right here. If I was going to move into standard algorithm, so that's what's next, it's the same thing here, except I'm not writing it out all the way, right? When I do the standard algorithm, again, I'm looking at my ones. I have 3, I'm taking away 5, I'm going to make a trade. I come over here to the tens, and instead of 2 tens, I'm now going to have 1. I traded in a 10, it's worth 10, and I have 3, so this becomes 13. 13, take away 5 is 8. 110, so I have 10 minus 660. I can't do that here, so I'm going to make that trade. So I'm going to have 600s left. I now have, instead of 110, I'm going to have 11 tens. 11 take away 6, or 11 tens take away 6 tens is 5, or 50. 600s minus 400 is 2. So if we just followed the list of steps, we end up with something that looks like this, but we don't understand where all those numbers came from. And sometimes kids just really struggle with this standard algorithm if they don't understand where those numbers came from. So using base 10 blocks, I would use base 10 blocks over and over and over again, and slowly move into something where let's talk about how we might write that. And as they get to this, we can then come to this kind of shorthand version of subtraction, which we call the US standard algorithm. Okay. So that's where we get to our standard algorithm. And questions, Michelle, that might have come up during those last strategies?
God, I was muted. I'm not seeing questions around this last strategy. There is the comment that a lot of my students automatically subtract the smaller number from the bigger number, no matter how the numbers are set up. So do you have any advice for addressing that?
So if we started with this base 10 block and we had the physical blocks and we're having to take them away, we can't take them away without having to make those trades. So it gets students away from thinking about taking that smaller number from a larger number, because they actually start with a set of blocks and they're building the second number. They're actually modeling taking that away by building it in another space. And so when I start with the blocks and I'm moving them here, there's no room for me to move. I have to make the trades. And as you start to understand how those trades look, they start to see that it isn't just about taking away that smaller number from the larger number. So we're going to move into a game that you might play with students. And again, I'm going to bring out my deck of cards. So I have a regular deck of cards. If you have number cards, you might use those number cards. But If not, a regular deck of cards will do. I have pulled out the 10s through the king. I've taken out the face cards. I have left in the aces as 1s, but if you think that an ace is going to kind of mess your students up, you can either write on the card or they can just take those out and not use the 1s. That's fine as well. So in this game, it's much like the addition game that we played last week. You're going to, each person will get, you could start with 3 cards. You can change this depending on the size of the numbers that you want to use. But I've picked 3 cards. So I have a 7, a 2, and a 3. I am going to make a 2-digit number and a 1-digit number, and then I'm going to subtract. So in this case, maybe I make the number 27, and I'm going to take away 3. So 27 take away 3 is 24. Now, the person, because you're going to play this kind of like the game War, you're going to compare. So I'm going to make my 2-digit number and my 1-digit number, I'm going to subtract. And then whoever has the smallest difference, or you could say the largest difference, whichever one you want, but you need to decide before you play. So I'm going to say smallest difference. We'll get to keep the cards. So if I did 27 minus 3 and I got 24, my partner is playing and they made 96, take away 4 is 92. I had the smaller difference. I would get to keep all the cards. Now, I then can get into kind of some strategy behind the game. I might say, if I have these numbers, 3, 7, and 2, what is the smallest difference that I can make? So if I look at 23 minus 7 is going to give me 16. 37 minus 2 is going to give me 35. 73 minus 2 is 71. So I would play around with the different kind of problems, and then I can find the smallest difference, and then I could be able to keep the cards. You may just want to do that as an activity. If I pick these 3 cards, you might have a student just work through what is the smallest difference that I can find, and they can come up with a whole bunch of different problems. So it doesn't have to be played as a card game. It could just be, here's my numbers. What kind of subtraction problems can you find? Can you find the one that would give me the smallest difference? You can also pick 4 cards, and now I'm going to make 2 2-digit numbers out of these cards. Again, looking for subtraction in this case. And again, there's that comparison piece. If you wanted to play it as a game and compare, the person with either the larger sum or smaller sum, decide beforehand, would get to keep the cards. But the idea isn't so much about the game and who gets to win the game. It's about you're engaging students in the math. You're getting them to do some subtraction and making it kind of a fun, engaging way where maybe they're not really thinking about it as math, but they're thinking about it as a game, but you're getting them to practice in their math facts, or their just problem solving. They might want a piece of paper so they can use the strategies that they know, so that they can write it down, especially if you turn this into sort of an activity. If I now have, 9, 3, 2, and 7, what are the 2-digit numbers that are going to give me the smallest difference? I'm probably going to need some paper to write down, and I'm going to be working through some of the problems. So this is where, if you were working with a small group of students, and you know that you need to differentiate for that group of students, you might be selective in the cards that you select for different kids. So I might give some larger numbers to one student, but I might give some smaller numbers. Now, when we're talking about subtraction, it's really about, we're talking about that difference. So even with some larger numbers, it doesn't mean that they are necessarily going to get the smallest difference. So it's some strategy built in there. You can do subtraction and you could still get, say, the difference of 3 with smaller numbers, but you could get the difference of 3 with larger numbers. And so it's really about differentiating for your students if you need to do that. So just a way to engage kids and get them kind of talking about the math and doing the math. One of the routines that I want to share, another way that we can engage students in some sort of subtraction, there's a website that has a routine called Splat. First, I'm going to bring my PowerPoint back up here. Let's see. All right, so there's the game idea. Just something different. I explained all of kind of the directions for that, but you can change up the directions. Again, it's not about winning a game. It's really about getting students active in the math. So Splat Routine, stevewyborny.com is the website where you can find Splat. He has all kinds of different routines. And so this is just one I want to share with you. And it does have some variety in the types of problems. So think about, how many blue shapes do you see? I'm going to say Splat. You may have a student count them all, but I don't want you to memorize the way that those necessarily look. I want you to think about, I'm telling you there are 10 blue dots. I've now, gee, the Splat has covered up some of my dots. How many dots has my Splat covered? So you would have a conversation with students and have them kind of think about that, think about how they might figure that out. They might say 8. Well, how do you know that? And have them talk about how they got their solution, because the way they got their solution could be different. Somebody might say, I started at 2 and I counted up to 10, or 10, take away the 2. And then you can reveal to them and they can count and double check for themselves. This is on this website, on stevewyborny.com. On his website, he actually sets them up as either PowerPoints, or you can get them in Google Slides. So you could pull the whole routine already prepared for you. I just pulled out a couple pieces so that you could see them. I do want to, oh, I stopped the share here, but I want to go to his website and show you some of the other types of Splat that you might find on his website. So you might find problems like this. Now this would be for your upper elementary. You might even move into middle school with this. If we were thinking about, there are 19 blue dots here, well, we can see 7 of them. So if we were just thinking about subtraction, we would say, okay, well, that means there's 12 blue dots that are hidden. If the Splat is the same color, it means it represents the same number. So the same number of blue dots are going to be under this one, as under this one, as under this one, as under this one. So if there are 12 blue dots total that are hidden, in this case, I'm dipping into division. I'm going to divide it by the 4, and I know that there are 3 blue dots under each one of those Splats. I just have this up as a model. I don't have it set up in the PowerPoint, so I can't reveal to you. But trust me, there are 3 blue dots under each one of those. You also might see, let me go to this one. He has a fraction series. So in this case, if I'm looking, there's a total that represents 7. And if I work with my students, I might say, okay, there's 1, 2, these are in fourths. So there's another whole here when I put these fourths together. So that's 3. I have 3 and 1/4 that I can see. And so you would have to talk with your students about how could you figure out what is underneath that, the Splat, what value is underneath there. And so in this case, we'd be looking for 3 and 3/4 would still be under this. And it could be that there's 3 blue dots and 3/4, 3 of the fourths that are under here. In other cases, it might be, there might be 1 blue dot and the rest could be the fractional pieces. But definitely this is for your upper elementary, or even and moving into your middle school. But there are lots of them that are like the first one that we did that are a simple straight subtraction. Some of them are numbers under 5. And so you could use them with young students as well. So
And
that
is the website free?
It is. All of these routines on his website are free. He also has, while I've got you here on the Steve Wyborny page, he has lots of routines for estimating, making estimates and refining your estimates based on some clues that you're given. He has things like this one here asks, how many of these blocks do you think are in here? And then it would give certain clues as to what that number could be. So students have to practice their estimation. So that's called estimistries. He has slides that work on subitizing. Subitizing is something we've talked about in the last 2 weeks. It's being able to recognize a number without having to count the number of dots. And so he has a bunch of subitizing slides and patterns that you can use with students to help them start to recognize those number patterns. But I like Splat. It's very engaging and entertaining for students. They can definitely play with the numbers on that page. Any questions that came up, Michelle? No? I'm going to break people out. One of the comments I got last week was about the breakout rooms. So I'm going to break people out just for a very few minutes, for about 5 minutes. Introduce yourself, and then I want you to talk about how you might use either the game that I shared with the cards, the subtraction game, the routines, the Splat routine, or anything you found kind of interesting in the new strategies around subtraction. So we'll take just 5 minutes. I'm going to break you out, and when we come back, I will give you all the details for the contact hour certificate. So let me break you out. And you should get a little picture that says join a room. So go ahead and do that for just about 5 minutes. So welcome back from breakout rooms. We'll give people just another few seconds because I think it will automatically kind of boot them out of the breakout room in about 15 seconds. So everybody will be back and we'll finish up. Now, it was a quick amount of time. I'm sorry that it wasn't longer. Sometimes those breakout rooms are just a great way to just kind of move through the thinking that you may have just learned, or to process that or reflect on that. And it's nice to be able to talk with others in that breakout room. It's just a smaller area. So welcome back, everyone, from your breakout room. Were there any lingering questions that anybody needed answered other than contact hours and that link? You'll have to unmute yourself, or you can just write into the chat box. So hearing none, I will share with you the the survey link information. I will get that also put into the chat box. So again, make sure that you are keeping track of your information as you're putting it in there. Make sure, please, that it is correct. All right, chat box.
Picture
I
is right
just,
for the numbers on mine.
there we go. I just posted it into the chat box. So if you are able to pull up that chat box, you should be able to click the link and go direct to the survey.
Can you do that again?
I certainly can.
Thank you.
There you go. It turned up as a blue link, so you should be able to click on it.
Thank you.
And if you are trying to type in the survey link, we have found that if you leave off the https:// and just type in the bit.ly link with the code into your address bar, that seems to work for some people. So if you're struggling with the typing in the link, and especially if you're watching this as a recorded session, please know that you may have to leave off that https:// You can always scan with your phone. If you open up your camera, it should take you to that survey, and it just needs your information.
What is it? 19?
Hi, Jen.
Yes.
It doesn't let me do it. This is the third week. Can I have it sent to me like you've been doing?
Yes,
Through
absolutely.
my email.
Yep, if
Thank
you just
you.
send me an email, I will zip it right back out to you. It's super easy that way for me to copy and paste it in for you. So if anybody does have trouble, feel free to just send me an email and I will certainly send you that link right out. Super easy to do.
All right. Thanks again, Jennifer. It was
You're
nice. Thank you.
Very welcome. Very welcome.
Hmm.